We've all seen it, right? You look up at the night sky and see those tiny, flickering diamonds of light. We just know that stars twinkle. It's in songs, in poems, it's just what they do. But the real story behind that twinkle is way more fascinating than you probably think. So what if I told you that stars don't actually twinkle at all? That entire beautiful, shimmering light show, well, it isn't happening out there in the vastness of space. That's right. That beautiful sparkling you see is happening right here, inside Earth's atmosphere. It's an illusion, a magnificent trick of the light created by our own planet. So let's dive into this. What we're really talking about is a sky full of incredible optical illusions. For centuries, people came up with all sorts of amazing stories to explain it. You know, that stars were alive or they were sending secret messages. But the real explanation is all about science, and honestly, it's even cooler. To really get this illusion, first we have to understand where the light is coming from. It all starts with these tiny points of ancient light. So a star is just a huge ball of burning gas, kind of like our sun. The big difference, it's just extremely far away. I mean, so far away that the light from some stars has been traveling for thousands of years just to get here. And this is the absolute key. Because of that insane distance, a star, no matter how giant it actually is, looks like a single tiny point of light to us. Not a circle, not a shape, just a pinprick. Now remember that. It's the secret to everything. Okay, now let's introduce the real star of the show. And it's not the star. It's our own atmosphere. This is where we get the atmosphere's turbulent dance. See, when you look up, you're not looking through empty space. You're looking through our atmosphere, which is basically a restless, churning ocean of air. It's got different temperatures, currents. It's constantly moving. Now, as that starlight enters our ocean of air, something called refraction happens. It's a fancy word, but you see it all the time. It's just the bending of light when it goes through different stuff, like how a straw looks bent in a glass of water. Same idea. So picture this. That starlight travels in a perfectly straight line for eons. Then it hits our atmosphere. It passes through one turbulent layer and bends. Then it hits another moving layer and bends again, and again, and again. By the time that single point of light gets to your eye, its path has been jostled around so much that it looks like it's flickering. That is the twinkle. Okay, so you might be thinking, wait a minute, if the atmosphere does this to starlight, why don't planets twinkle? It's a great question. And the answer to this really proves the whole theory. Why treat stars and planets differently? It all just comes down to distance. Stars, like we said, are so far away, they're just single points of light, which are easy for the atmosphere to knock around. But planets, they're much, much closer, so they look like tiny but distinct disks. This means that while the light from one side of the disk gets bent up, the light from the other side might get bent down. All those little distortions just average themselves out, and what you get is a steady, constant glow. So here's a super simple guide for the next time you're outside at night. If you see something twinkling and flickering intensely, you're looking at a star. If it's shining with a calm, unwavering light, that's almost certainly a planet. For the final piece of the puzzle, we have to go where the atmosphere can't bother us. We have to see what it's like from space. And the difference is, well, it's night and day. From down here on Earth, we see a constant flicker. But from space, an astronaut or a space telescope sees that same star shining with a perfect, steady light. The reason is simple. There's no atmosphere up there. Without that turbulent ocean of air to bend the light, it just travels in a perfectly straight line. This is exactly why we send telescopes like Hubble into space, to get above the twinkle and see the universe with perfect clarity. So maybe instead of thinking of it as just a distortion, think of it like this. That twinkle is the beautiful final chapter of an epic story. It's light that has journeyed across the cosmos for maybe millennia, only to perform a shimmering, chaotic dance in our atmosphere in the very last second before it reaches you. So let's wrap it all up. Stars themselves, they don't twinkle. They're steady beacons of light. The twinkle we see is just our turbulent atmosphere bending their light all over the place. Planets are closer, appearing as disks, so the effect gets averaged out and they shine steadily. And of course, in space, with no atmosphere, there's no dance at all, just a perfect, clear view. So the next time you find yourself under a clear night sky, what are you going to see? Will you just see a twinkling star? Or will you see the incredible story of ancient light on the final turbulent leg of its long journey, putting on a show just for you?